Good morning, class. Today, we're going to continue some basic concepts of chemistry. Now, today we're going to study about some basic physical quantities. Okay, so what are the basic physical quantities which we use? First, length. Second, mass. Third, time. Fourth, electric current. Fifth, temperature. And sixth, amount of substance. Finally, luminous intensity. Okay, so now what we have to do is, these are the basic physical quantities. Now we have to write their SI units. Okay, so the SI unit of length is meter. The SI unit of mass is kilogram. The SI unit of time is second. The SI unit of electric current is ampere. The SI unit of temperature is Kelvin. The SI unit of amount of substance will be mole. The SI unit of luminous intensity is candela. This is mole. This is Kelvin. This is ampere. This is seconds. This is kilograms, and this is meters. Okay, so basic physical quantities and their SI units, these are very important. So some things will be very different for you because you might have not heard about moles. Okay, we'll study that later in this chapter. Now the next topic is mass and weight. So the question will be like, differentiate between mass and weight. Okay, differentiate between mass and weight. So we can make two columns. Okay, mass is the amount of matter present in a substance. Okay, the amount of matter present in a substance is known as its mass. Weight is the force exerted by gravity on an object. Okay, mass is the amount of matter present in a substance, and weight is the force exerted by gravity on an object. Okay, so what is the difference between these two? Like, if I say, like, what is gravity? It's the force exerted by the earth on us. So the force exerted on us on the earth and on the moon will be different. Okay, so it means that Suppose our weight on Earth is 60 kg. So in the moon the gravity of moon is approximately 1/6 of the gravity on Earth. So the force with which Earth pulls us and the force with which moon pulls us, the force pulled by the moon will be 1/6 of the gravity exerted by Earth. So this means that weight depends on gravity, but the amount of matter which will be present in us on the Earth and on the moon will be same. Okay, so I was saying, if you have to differentiate between mass and weight, the first point is the amount of matter present in a substance is known as its mass, and the force exerted by gravity on an object is called its weight. The second important point is mass is always constant, but weight varies from place to place. Okay, weight varies from place to place. Okay, now the next thing which we're going to study is significant figures. Okay, so before studying significant figures, I need to tell you two things. One is precision and the other is accuracy. What is the difference between precision and accuracy? Okay, I'm not going to give you the definition right now. First, I'll tell you what it means. Suppose your teacher gives you a rope, or she gives you a rope, and she tells you to measure this rope using your own scale. Okay, so teacher has a scale. According to her, it measures 10 centimeter. Fine, but everyone has a different scale. Since everyone has a different scale, the measurement will be different. One student gets it at 9.2 centimeters. Another student gets it at 9.5 centimeter. Another one 10.3 centimeter, and one gets it at 9.9 centimeter. So if you have to choose one of these answers, okay, if you have to choose one of these answers, then what would that be? It would be the last one. Why? Because 9.9 would be approximately equal to 10 centimeter. Okay, so you chose this. So this means accuracy. So the value of 9.9 centimeter will be the most accurate value. Okay, so why did we say so? Because this value is closest to the true value. This 10 centimeter will be true value. So this 9.9 will be most closest to the true value. So, okay, understood this? Now, precision. What is precision? Suppose you have to measure something, like, again, you have this rope. Now it measures 10 centimeter again. Now, one student measures it as 9.9. Okay, the other one gets it as, like, if you have a scale, then the scale will have many divisions. So suppose you have very, very minute divisions in your scale. You have to suppose this. So one is 9.9, the other is 9.92. Third value is 9.95. The fourth value 9.956. Another one you get 9.97. Another one 9.978. Okay, so what according to you is the most precise value? Okay, we're talking about precision. The most precise value will be this. Can you tell me why? Because first it was 9.9, then increased to 9.92. You got to know one digit more than the previous one. Okay, now the next one, the actual value you have to remember it's 10. Third value you have more accurate, like 9.95, which is closer than 9.92. The next one, the fourth one, you're getting 9.956. You got 3 decimal points. Fine. Now, next one, 9.97. 9.97 is better than 9.95, right? So, now, next one, you got 9.978. So, the most precise value will be this. So, what is actually a precise value? As the number of decimal places increases, you get more precise value. So, for precision, you have to look at the decimal places. Okay, so this was easy. Now, I was telling you about what? Significant figures? Okay, so what are significant figures? The definition is significant figures are meaningful digits which are known with certainty. They are meaningful digits which are known with certainty. Okay, now what are these? Now the question comes, calculate the number of significant figures in the following. Okay, so first question is, like I'll tell you, the first rule regarding significant figures is all non-zero digits are significant. All non-zero digits are significant. So what is the meaning of this? This means that, suppose I'll take any number like 185. So non-zero, there is no zero in this number. All 3 digits are non-zero digits. So the total number of significant figures in this is 1, 2, 3. Easy? Next, if I say 2, 9, 4, 7, 8, how many significant digits do I have? All are non-zero digits. So 1, 2, 3, 4, 5. 5 significant digits. Easy? Now, next, another example. If I have 2, 0, 9, 8, I have to count the number of significant digits or significant figures, and I told you, calculate okay, this comes under the next part. Okay, you don't have to think about it now, I'll tell you. Leave this for now. So all non-zero digits are significant. Okay, now the next point is the second point. It is zeros preceding to first non-zero digit are not significant. zeros preceding to first non-zero digit are not significant. What does this mean? Suppose I write 0.002. Okay, so which is the first non-zero digit? Which is the first non-zero digit? 2 zeros, zeros. Preceding. What is the meaning of preceding? It comes before. Okay, so zeros preceding the first non-zero digit are not significant. First non-zero digit is 2 and the zeros preceding these are 3. So these zeros, we are not going to count these 3 zeros. So the number of significant figures, this particular number, that 0.002 is 1. Easy? If I write 0.25, okay, 0.25. So how many significant digits? 1, 2. Easy? Hmm? Now, the third point. The third point is zeros between two non-zero digits are significant. Sorry. Zeros between two non-zero digits are significant. So if I have a number 2.0078, okay, so we have to calculate the number of significant figures in this particular number. So zeros, we have zeros between two non-zero digits, which are non-zero digits 2 and 7. These zeros lie between these two non-zero digits, so they are considered to be significant. So the number of significant figures 2.0078 equal to what? 1, 2, 3, 4, 5. Easy? Next. If I say 1.107, okay? Total number of significant figures 1, 2, 3, 4. We count this 0 because it comes between two non-zero digits. Okay? Now, the next one is fourth point. The fourth point is zeros at the end or right of a number are significant provided they are on the right side of a decimal point. Okay, zeros at the end or right of a number are significant provided they're on the right side of the decimal point. What does this mean? Suppose I have a number 29000. So, can you see any decimal point over here? No, I cannot see. So, the total number of significant digits will be 2. 1, 2. These won't be counted. But if I write this, now to see a decimal point, so the number of significant digits will be 1, 2, 3, 4, 5. I'll tell you once more. If I have a number 1250, okay? Now, how many significant digits? You cannot see a decimal point, so total number of significant digits will be 1, 2, 3. But if I write 1250 point, then total number of significant digits will be 1, 2, 3, 4. Why 4? Just have a decimal point over here. Easy? Now, next one is if I write 780.0, 780, 780.00, 780.000. So, you have to calculate number of significant figures. One, two, three, four. Why did I count this? And why did I count this? Because there is decimal point. So 1, 2, 3, 4. Okay, next. This one. 1, 2, 3, 4, 5. Why did I write 5? Because there's decimal point, so I need to count all the digits. If I did not have a decimal point and my number was this, then total number of significant figures will be equal to 2. How? 1, 2. This won't be counted. But if I write 78000 points, then I have to count these zeros as well. Understood? So, what is the answer? The answer is 1, 2, 3, 4, 5, 6, 7. Easy, right? Now, next one is next topic. The next topic is dimensional analysis. Okay, what do you mean by dimensional analysis? Dimensional analysis. It means that you have to convert one unit to another unit. Suppose I have a question. You have to convert 3" into centimeters. Like how many inches, how many centimeters is 3". Okay, so how will we calculate? If I tell you how many centimeters is 1 meter, you'll say 100 centimeters. That is easy, very easy. You need to know the relationship between inch and centimeters. Okay, few things you have to learn. First is 1 inch equal to 2.54 centimeters. Okay, so 1 inch equal to 2.54 centimeter. Then 3 inch will be equal to 1 equals this, 3 equals 2.54 into 2. What is the answer? 7.62 centimeter. This is very easy. Just need to multiply this number with this. Okay, next one. You need to convert 2 liters into meter cube. Okay, 2 liters meter cube. So what else do you know? We know that 1 liter is equal to 1000 milliliters. This we are studying since we were born. Okay, now another thing which you need to learn now is 1 milliliter equal to 1 centimeter cube. Okay, so before I start this, I'll tell you something which is very important. It's a table for you to convert some digits into a number. For example, it goes like this. This is very, very important. Milli, centi, deci, meter, deca, hecto, kilometer. What does this mean? Like, how do you convert this? I'll give you an example. We all know that 1 meter is equal to 100 centimeters. How did you get this? How did you get this? See, which is the bigger unit? Meters is bigger unit. So where is meter? Over here. Where is centimeter? Over here. So you need to convert meter to centimeter. Now, so you have to go from meter, the bigger unit, meter, to the smaller unit, centimeter. So how many steps you need to jump? 1, 2. So from bigger unit to the smaller unit, first write 10 and then count the number of steps 2. This is your answer. Did you understand what I said? No? I'll tell you once again. You need to go from the bigger unit to the smaller unit. Bigger unit to smaller unit. So, how many steps did you jump from meter to centimeter? 1, 2. Each step is a multiplication of 10. Okay? Each step you take, you have to multiply with 10. So, instead of writing this 10, you have to write 10 and then how many steps? 1, 2. So write number of steps. Therefore, 1 meter is equal to 100 centimeters. Easy? Next one. Now the next one is need to convert. If I say how many hectometers, sorry, how many millimeters are equal to 1 hectometer? Need to convert hectometer into millimeters. So which is the bigger unit? Hectometer? Millimeter is a smaller unit? Okay. So what I told you, first you write 10. Count the number of steps from bigger unit to smaller unit. 1, 2, 3, 4, 5. So the answer is 10 raised to 5. So another one. The next one is how many, if I say need to convert kilometer into decimeter. How do you do this? It is a bigger unit, kilometer, it's a smaller unit, decimeter. Now, the bigger unit is equal to 10 raised to how many steps? 1, 2, 3, 4. Okay, easy. What if you have to come from the smaller unit to the bigger unit? What we did is from the bigger unit to smaller unit. Now, need to convert the smaller unit to the bigger unit. How do you do this? If I write 1 centimeter is how much decameter? So how would you convert this? You need to come from the smaller unit to the bigger unit. First we were doing the bigger unit to smaller unit. Now what we're doing, we're converting smaller unit to bigger unit. How? First write 10. Now since you're coming from small to the big one, you need to write minus. Number of steps, 1, 2, 3. This is the answer. I'll tell you one more. One decimeter equal to how many kilometers? Which is the bigger unit? Which is the smaller unit? Okay, so we have to start from smaller unit to the bigger unit. Four steps. So 1 decimeter is equal to 10 raised to minus 4 kilometers. Easy. Now another short trick for this is, I'll tell you. Okay, now we need to convert from This is small unit. This is the bigger unit. We need to convert the bigger unit to the smaller unit. We have to multiply it by 10. We need to convert the smaller unit to the bigger unit. We need to divide it by 10. Okay? Or what you can do is count the number of steps and write 10 raised to that number. If you have to come from smaller unit to the bigger unit, count the number of steps and then write 10 raised to minus x. Okay, understood? So we were doing this. 2 liters equals how many meters? You have to convert this. So I already told you few things which you know is 1 liter is equal to 1000 milliliter, and 1 milliliter is equal to 1 centimeter cube. The standard, you have to learn this. Okay, now let's come back. We need to convert liter into meter cube. Okay, so liter and milliliter. We know the relationship between liter and milliliter, right? Then we know the relationship between milliliter and centimeter cube, fine. Then we need to convert centimeter cube into meter cube. First, liter should be converted. First, liter should be converted into milliliter. Then milliliter should be converted into centimeter cube, and centimeter cube should be converted into meter cube. So there we get direct relationship. Okay, so how did we do this? First, liters into milliliter. Okay, so 2 liters, if 1 liter is equal to 1000 milliliter, then 2 liters is equal to 2000 milliliter. Okay, so I can also write it as 2 into 10 raised to 3 milliliter. Okay, next, I need to convert milliliter into centimeter cube. So, milliliters is if 1 milliliter is equal to 1 centimeter cube, then 2 into 10 raised to 3 milliliter would be equal to 2 into 10 raised to 3 centimeter cube. If 1 equals 1, 2 into 10 raised to 3 equals 2 into 10 raised to 3. Now, the next is need to convert this into meter cube. Now, this one looks difficult. Actually, it's very easy. See, we all know that 1 meter, we all know that 1 meter is equal to 100 centimeter, or you can also write 1 centimeter is equal to 1 by 100 meter. 1 by 100 meter can be written as 10 raised to minus 2 meter, right? So 1 centimeter is equal to 10 raised to minus 2 meter. If I cube both these sides, what do I get? 1 into 1 into 1. Here, 10 raised to minus 2 into 10 raised to minus 2 into 10 raised to minus 2. What do I get? Here I get 1 centimeter cube, and here I get 10 raised to minus 6 meter cube. So now we know the relationship between centimeter cube and meter cube. What is it? Okay. Now, what is the next step? We left it over here, right? What we have is 2 into 10 raised to 3 centimeter cube. We need to convert it to meter cube. Okay? Now, what we did is, if 1 centimeter cube equals this, then 2 into 10 raised to 3 centimeter cube would be equal to what? 2 into 10 raised to 3 into 10 raised to minus 6 meter cube. What we did, instead of writing 1 centimeter, I'll do it once again if you didn't understand. We can write this as 2 into 10 raised to 3 into 1 centimeter cube. Now, what is the value of 1 centimeter cube? 10 raised to minus 6 meter cubed. I'll write 2 into 10 raised to 3 into 10 raised to minus 6 meter cube. Okay, so this will be equal to 10 raised to 3 minus 6 meter cube. That's equal to 2 10 raised to minus 3 meter cube. Therefore, 2 liters will be equal to this. I hope this is very clear to you. Okay? I hope this is clear. If I ask you one more question, convert 5 liters to decimeter cube. This is very easy. So, first, liter can be converted into milliliter. Milliliter can be converted into centimeter cube. And finally, centimeter cube has to be converted into decimeter cube. Okay, so 5 liters will be equal to 5,000 milliliters. Okay, then 5,000 milliliters will be equal to, I told you already, 1 milliliter equal to 1 centimeter cube. So 500 milliliters will be equal to 5,000 centimeter cube. Okay, now we also know, do you remember the relationship? What you need to convert is, you need to convert centimeter into decimeter. How many steps? One step. So the bigger unit to the smaller unit. So 1 decimeter will be equal to 10 centimeter, because you went from bigger unit to smaller unit. Okay, so 1 decimeter equal to 10 centimeter. Now, if 1 decimeter equal to 1 centimeter, sorry, 10 centimeter, then 1 decimeter, if we cube it, 10 centimeter also has to be cubed. We will get 1 decimeter cube is equal to 10 raised to 3 centimeter cube. Okay, so if 10 raised to 3 centimeter cube equals 1 decimeter cube, then 1 centimeter cube will be equal to 1 by 10 raised to 3 decimeter cube. That will be equal to 10 raised to minus 3 decimeter cube. Okay, now what was our question? We had 5,000 centimeter cube.